Hello, today we'll start with monotonic functions. So what is a monotonic function? A function which is increasing or decreasing in a given interval is a monotonic function. They are of two types. Here you have an increasing function. An increasing function is when we consider two numbers x1 and x2 which lie in the given interval such that x2 is greater than x1. So for these values of x2 and x1, when we put in f of x, we must get f of x2 is greater than f of x1. We can see it in this diagram over here. If we consider x1 over here and x2 over here, here x2 is greater than x1, and we say f of x2 over here is greater than f of x1, hence is increasing. Then you have a decreasing function, where again you take two numbers x1 and x2 which lie in the interval such that x2 is greater than x1. But over here your f of x1 is greater than f of x2. So if we take x2 over here, x1 over here, like in this region x1, in this region x2 at this point, so then f of x2, the y value is lower than that of f of x1, hence this is decreasing. Now we can check the increasing or decreasing properties by using the first derivative as well. If f dash of x is greater than 0, the function is increasing in a given interval, because your f dash of x is a slope. So at any point over here, the slope is going to be positive, hence your first derivative is positive. So we are checking with greater than 0. We're checking if it's positive, we see the function is increasing. Same way, f dash of x less than 0, we're checking for a negative slope over here. Here, since f dash of x is less than 0, we see the function is decreasing in the given interval. And if we say f dash of x equals 0, function is constant in the given interval. So we can see over here your f dash of x will be negative, your f dash of x is positive, and here it is constant. Here your f dash of x equals 0. Now we can test if a point is an extrema, so it can be either a maximum or a minimum, using the first derivative test. This property of monotonicity we can use to find the extrema. So if value of f dash of x changes from negative to positive at a critical point. So at a critical point, we'll check before the critical point if it's negative, and after the critical point if it's positive, the value of f dash of x. That means that critical point represents a minimum. Same way, if we check before and after critical point, if it's initially positive and after the point it becomes negative, we say that point is a maximum. If value of f dash of x has the same sign, the point is not an extrema. So it means that every critical point will not be an extrema. That's a point to note. We can take an example. Find critical point of f of x equals x cubed minus 12x minus 5, and identify the interval where f is increasing and decreasing. So f of x equals x cubed minus 12x minus 5, which is a polynomial of degree 3, and hence it is continuous and differentiable everywhere. So we find the first derivative and we take it out common. We get 3 times x square minus 4 for the critical point. F dash of x equals 0, or it has to be undefined, then only a critical point will exist. Over here we will not get an undefined value, so we say your f dash of x has to be 0. We get x is plus minus 2. Since this is continuous and differentiable everywhere, indirectly we are telling the domain or the region we have to consider is negative infinity to positive infinity. So at 2, we know there's a critical point, so we divide it into 3 regions: negative infinity to negative 2, negative 2 to 2, and 2 to infinity, because your monotonicity, as you can see over here, is for a particular region. So our intervals are here. Evaluated f dash. So I'm putting some point between minus infinity to minus 2. I can take any point. I can take minus 2.1. or I can take say minus 10 also, but to keep it simple I'm taking minus 3. Substituting minus 3 up here in 3x square minus 4, we get 15. Same way for minus 2 to 2, 0 lies in the middle, so I just take 0. 2 to infinity I'm taking plus 3. Now just be careful not to take minus 2 or 2 or infinity, because you're not including those values. These are open intervals. So over here your sign of f dash or at minus 3 is positive, so it's positive everywhere in this region. Over here we get minus 12, so the sign is negative. Over here we get 15, so the sign is positive. Since the first derivative is positive, here it's increasing. First derivative negative is decreasing. First derivative positive is increasing. And that's how we can make a rough graph of it this is not the exact shape obviously, but we can make a rough sketch. So from negative infinity to negative 2, it is increasing. Here you can see it's increasing. From negative 2 to positive 2 is decreasing, as you can see it's going down, and from 2 to infinity is increasing again. Now you can find the values of y by putting the value of x. So the critical point value of x, if you put it into your f of x over here, x cube minus 12x minus 5, you'll get the corresponding values of y. So that these 2 points, are your extrema. You cannot find the extrema at an end point over here because it's negative infinity and infinity. So we just say that, okay, for negative 2, the extrema is 1. For 2, it's minus 21. So your maximum is 1. Your minimum is minus 21. But just because a critical point exists does not mean that the behavior will change. So we can take an example over here. F of x is x power 4 by 3 minus 4x power 1 by 3. First derivative gives you this. 4 times x minus 1 by 3 times x to the power 2 by 3. For this, the critical points are 0 and 1, obviously, because your f dash of x is 0 for x is 1, and it's not defined for x is 0. So our intervals, again, we're splitting it. Since this is a polynomial only, we're splitting it negative infinity to 0, 0 to 1, 1 to infinity. Over here, on calculating the value of f dash of x, we'll get this as negative, so your function is decreasing. For 0 to 1, so if you take it at half, for example, then to your function is decreasing only. So even though your critical point is there, it does not mean that the monotonicity will change. Over here it's decreasing, and then it goes to increasing. So just be careful that if you see a critical point, it does not mean that it's changing.